Fantastic, we are. Hi everybody, we have another board repair to do. This one is an A1708 that's going to be a 2016 to 2017 13-inch MacBook Pro. This was the very last model that had a modular SSD. After this, all SSDs are permanently soldered onto MacBooks. But that's not the issue that we're having here. Hey, what's up, Tim? It's good to see you. This one appears to have someone plugged in a third-party adapter, and I think it drew too much power from one of the CD32 chips, therefore killing it. This one actually has a hole in it, as well as damaging the USB 3.0 IC. So let's go ahead and just jump straight into this. Thanks for joining us, Toby. So if we go ahead and we go over to our microscope camera, the first thing we can tell, this chip right here is blown. Now, this chip is responsible for USB 3.0 activity on the 2017 MacBook Pro, this A1708. There's two different versions of the A1708, 2016, 2017. The 2016 does not have this USB 3.0 chip on it, while the 2017 does. Now, the thing that's unfortunate is that when we look at our schematics, that chip is not present, even though this schematic says this is for an 820000840, which should be 2017. It's not. It's actually a 2016 schematic or board view. So this is where this chip would exist. Completely unpopulated, unfortunately. So that chip is non-existent. It doesn't pop up in the schematic either. However, I'm able to read the data off of the, read some etching on the chip itself and Nintendo Switch. Interesting. I didn't know the Nintendo Switch had that. But we're able to read some of the etching on this chip and compare it to another board that we have here. So here I have a MacBook Air logic board, and whenever I look at the schematics, that chip matches up with the same chip on this A1708. So I'm able to read that this one here, it's a Pi 3 USB 3224. That's the model number if you're trying looking for it. Fortunately, DigiKey and Mouser no longer have that. They deem it an obsolete chip. So we either have to pull the chip off of another MacBook, in this case a MacBook Air, or we have to end up ordering from AliExpress. So in this instance, I do have the chip. We're going to go ahead and pull it off. But normally when this particular USB 3.0 chip dies, it's also due to a bad CD32, if I can get my right cameras going. So if I flip over the board, you can see here, this CD32 completely exploded. So I'm assuming what happened in this instance is that maybe a third-party adapter with like a 10 USB hub, something ridiculous pulling a lot of bandwidth, just killed the CD32, which ended up killing the USB 3.0, or vice versa. It killed the USB 3.0, which shorted and ended up killing the CD32. So we're going to go ahead and replace both of these at the same time. According to Tim, Mobile Centrics may carry this part. Admittedly, I haven't looked at that. I'll have to check that out afterwards because I do need to stock up on these chips as I'm running out of donor boards for pulling this particular chip from. So we don't need to do any testing on this one. We can just go ahead and start replacing parts. So what I'd like to do when repairing this particular chip is that there is this sticky felt, almost like a grounding tape for our USB Cs right here. And I'm going to just go ahead and peel it because as we heat this up, that's going to melt and it's going to stink. It's going to smell really, really bad. And it's probably toxic, truthfully, too. So I'm going to go ahead and remove that. And what we want to do is keep track of our orientation of the chip since we can't reference our schematic. And it's hard to see with this camera, but our pin 1, our dot right here, is pointing up in the top left connection. So let's go ahead and get our rework station heated up, our fume extractor turned on, and put a little bit of flux on this guy. And I need to adjust my heat and my output because I was working on a Nintendo Switch. And I'm glad I'm done with that one. Admittedly, I'd spent months working on that one. But we are done. We're no longer doing Nintendo Switch repairs after that one. That one was a real eye-opener. Just gonna stick to MacBooks. and the occasional iPhone board repair. So right now I'm using about 480, my bad, with an output of 110. The max output on here is 120. Now, since this chip has shorted and it's kind of melted itself, probably going to have a little bit of difficulty right there on the right side where it died, and I want to make sure that I gently lift up so I don't pull any potentially fried traces. Because when they get this hot and short, what tends to happen is that the traces actually weld themselves. So it requires a little bit more TLC to remove. And if we just pull off too quickly, we'll end up pulling the trace with it. And then we have to run a jumper wire. And so I'm getting stuck right where the trace is at. These traces may be too far gone to save. And I think that is the case. You can see we got pretty gross looking damaged fiberglass in this area. So we're probably going to have to run some jumper wire because I don't think that's worth saving. What makes this a little tricky is we're going to have to reference another logic board to see where this particular chip or this particular pin on this chip goes to, because it is barely hanging there. It's not worth keeping, so I'm going to go ahead and remove that. And you can see the pins right above it are completely gone. So let's gently remove this. Okay. Now to see what we're working with, I'm going to go ahead and wick up all the existing solder. So this one's going to involve some trace repair. Because that chip was too far gone. So that tells me whatever device was plugged into this drew a lot of power, that it basically turned a short into a welded spot, a spot weld. That's a lot of power. Okay. So we're just going to use our goot wick here and our soldering iron and go over these pins. Make sure not to get stuck. And let's clean this up with alcohol and see what's left of the trace. So it's a pretty severe burn. Both of these chips, both of these traces pretty much are non-existent. And we could try to salvage this one. If we get a sharper scalpel, we might be able to actually expose where that trace goes to and make a jumper wire. We may actually be able to make a jumper, like a jumper pad for both of these. So I need a sharper scalpel for this. So I'll be back in 1 second while I change out my blades. Because this scalpel is all sorts. Did some hear about the news that the Face ID from iPhone is repairable? I haven't looked into that, but I have seen in the past, a couple years ago, there was a like a device you could pair with for fixing Face ID. And what was sketchy about it is that Face ID actually has a safety locking mechanism that if any of the sensors, like the light emitting dot projector, is damaged, for safety reasons, Face ID turns itself off, because this is infrared light, and if you are exposed to the wrong frequency, you can actually cause blindness. And I don't know if repairing Face ID is worth potentially going blind in a couple of years. So what this device was designed for was basically bypassing that override, that safety override, that could potentially lead to blinding issues. So I never messed around with that personally, but I haven't looked into any new Face ID issues or Face ID repairs. Okay, as we touch this trace more, it's just falling apart. In fact, I think I can actually see the ground connection underneath it. I'm not sure if that's all the same connection, but this thing is just fraying. Yeah, it's all just basically ash. And this is all fiberglass too. So the fiberglass just melted essentially. Okay, so I'm going to get my multimeter and probe those two exposed contact points to see if they're grounded, because I don't want the trace to be potentially touching a ground layer. And that looks to be okay, surprisingly. No ground. And then now, I'm going to find a donor board that already has this particular chip removed, so that I can measure the diode mode measurements. It might vary because USB-C on the CD32 on. Here we are. So I have another A1708 here. The mic is coming out. Okay. Let me try to reset that. One, two, three. All right, you can let me know if that sounds any better. I may have just walked too far away from the receiver. Okay, so I have another A1708 here that we've already pulled the USB 3.0 chip off of. As you can see, this one also has a damaged die, so the CPU just completely died on this one. So let's get a diode mode measurement of those specific pins and compare them. So it looks like it is the 4th and 5th pin down from the top. So let me get a base measurement and put my multimeter into diode mode. I don't have my multimeter from home that has the on-screen capability, so I'll just do this analog. So we said the 4th and 5th one. So here I have OL. Here is also OL. So now on our patient board, let's compare. Okay, so I have 0.1 on this side and 0.1 or 0.09 on this one, and that could be because of our CD32. So I guess before we address that, let's go ahead and remove our CD3215 as well. And there's a component right next to it that looks like kind of got a whole bunch of flux something burnt onto it. But let's remove this chip as well. So judging by such a low diode mode measurement in that specific spot, I'm thinking the CD3215 failed, and when it died, it took the USB 3.0 chip with it as well. I'm going to get some different tweezers for this. So I haven't looked into it, but I heard that Tim from TCRS Circuit is selling a new type of flux that smells like chocolate. Don't think that's necessarily the selling point of it, but someone in the Logic Board Repair Facebook group was talking about that. Be nice to have a different smell when doing board repair. Just imagine you're removing a CD3215 and it smells like baked cookies. And it looks like I removed or shifted a couple of resistors when I pulled up that CD3215, so I'm going to have to shift those all back into place once I finish wicking this up. All right. David says white or black chocolate. I'm not sure. I would imagine black chocolate. I've never heard anyone call it black chocolate. Okay. So as we heat up a replacement CD32, those will kind of wiggle themselves back into place. So now that we have this up, we'll check the diode mode measurements again on these chips. Or not on these chips, I'm sorry, on these particular pads. See if we have a short. Okay. Just making sure that we had a good beep. And we're still getting 0.1. That leads me to believe that we still have a partial short somewhere else. Well, this one component in particular looked a little funny. Let's take a look at our schematics and see what that is. I understand what you were saying, David. I'm just messing with you. Dark chocolate. So this is going to be a capacitor connected to UPC XBSS. The XB is going to be the name of this chip on the schematic. The UPC, I'm not exactly sure what that is off the top of my head. But there was a lot of grossness on this chip. Let's just measure to ground what this is, resistance-wise. Okay, so we're in the mega ohms there, so nothing obviously damaged on that side. Now, I did work on one CD32s, and one of these coils the line a coil was connected to was shorted, which went directly to the CPU. But that seems fine according to the multimeter. No obvious short on that side. So now I'm just kind of probing everything in this general area to see if we have a low measurement Because my fear is that we go ahead and we replace that USB 3.0 chip, and it's just going to end up dying again. What is this? This is 1 ohm on this side. This is 1 ohm on that side as well. This could be one of those ground resistors though. So let's look at our schematic and see exactly what that is. Okay, so it is a resistor, and the other side is ground. Let's see how low of a resistor this is. A 0 ohm resistor. Okay, so that's fine. That is fine. That means that on the other side of this resistor is ground. So that is okay. David says must be a data line, not a power line. Okay. Be just my luck if one of the components that moved shifted out of the way was one that was partial short. Okay, so far so good. Nothing alarming on my multimeter with these components. Hopefully it's not anything in the actual Thunderbolt chip. If anything, it's actually probably the layer itself where the trace was welded. Because it wasn't burnt, it was pretty much welded at this point. And because you have different layers of your logic board. Your motherboard is kind of wafered, so there's several layers, and you have traces that are known as vias that go through the different layers of the logic board to connect to other parts. Yeah, all this looks perfectly fine. And what can happen is when the actual the trace essentially catches on fire in this case, it will then try to touch a ground layer right next to it, and then can actually make that specific line shorted. And how we fix that is by digging the trace out of the line. But you have a short in my opinion. That's exactly what I'm thinking too. Let me get another measurement in diode mode just because admittedly the board was hot. Want to make sure that didn't mess with anything. Yeah, now we have a reading of 0.2, still 0.1. So I'm thinking that's what happened here is part of the board has actually bridged and is touching itself. So of the different layers, it melted, and since we have ash, we've already burned through 1, maybe 2 layers, and the layers are probably touching each other. So now comes the gross part where we actually have to dig part of the trace out to make sure that we can relieve that short. Because if we try just replacing this chip or even running a jumper wire, it's just going to immediately fail. So let's see what we can do here. I have seen some instances where people will actually take a drill and drill through the board. I never like doing this. This is always cringeworthy. Admittedly, if this board, if we can't resolve this short, I'd say probably in the next 20 minutes or so, then this board would be perfect for a board replacement. Because the A1708, since the logic board has a modular SSD, fortunately in this case, the logic boards are actually fairly inexpensive. It's actually a reasonable replacement price. And especially for a 2017 6-year-old logic board, we could probably end up replacing the logic board at a cheaper price if it turns out that we can't resolve this short. And so this looks like this is a trace, or a via for a trace. And I'm just kind of going through and just scraping away the ash. I'm really not trying to dig into the fiberglass right now. Just barely grazing the parts that are already burned up. Okay, and see that trace, I just barely poked it and that via just kind of jumped right out of there. David says that he's seen a stream from Tim for data recovery. That was a big hole at least. So it sounds like Tim Herman had to dig a hole or drill a hole into a MacBook to recover data. I admittedly haven't been keeping up with board repair streams from other technicians. So like Paul Daniels, I know he had one very similar where he did data recovery by drilling a hole. I actually haven't seen that one yet. What's up? Mm-hmm.
It says that we replaced the home button because we couldn't fix the home button.
Oh, is that Oh, yeah. So unfortunately, the home button had been replaced by a third party, or been replaced, and I don't think they told them that. Like another shop.
Okay.
And her main focus was to get like Touch ID working again. Unfortunately, we won't be able to ever bring that back.
Okay. So the home button.
Yeah, I mean, it works for an aftermarket button.
Okay.
Yeah. I put everything back together, because the other store messed up. Yeah. Okay, so now I have no traces. Let me evaporate some of this. Yeah, so now there's absolutely no trace. I just barely grazed everything that was in this crater here, and there's no via left behind. So what makes this a little tricky is we need to now figure out where these specific lines go to, and we don't have that on our schematic. So this makes things a little tricky because I do have another board here where we've already removed this part of the heatsink underneath the that covers the Thunderbolt controller, and we were able to measure exactly where that goes to on some pads and run a jumper wire. But our schematics, since our schematics are not for a 2017 but instead for a 2016, just straight up don't have anything there. So let me get a donor board. A donor board that's already had the, sorry, I'm thinking real quick. So yeah, let me go ahead and get another donor board real fast that already has this heatsink removed. Trace, pun intended. Where are those traces? Ah, here we go. So we have ourselves here another A1708 that has also a dead CPU. Common issue with these guys here. And I've already removed our USB 3 chip as well as the cowling, the heat shield, that covers our Thunderbolt controller. I need to apply some WD-40 to that. I'm so sorry, guys. Okay, so the last time we worked on one of these, we were able to pinpoint that one of these, or these traces, actually correspond to any of these points here that the USB-C plugs into. So I'm going to get my multimeter, first put it into diode mode and make sure that I don't have a strange difference in resistance here. And that is correct. In diode mode, I'm still getting OL, which is exactly what the other dead CPU donor board had. So the fact that we were getting any reading at all on our patient board does mean that there is something that is partially shorted. So now what we're going to do is we're going to take our multimeter, put it in continuity mode. I'm going to touch the 4th pin from the top and just basically probe every one of these points to see which one of these it connects to. And hopefully it connects directly here and not a via that goes to the other side of the board for our CD3215s. And I might not be so lucky. Yeah, not a single one of those is connected to this particular chip. So, if I had to guess, what's going on here is that the vias go through the other side of the board where the CD3215s are at. And without the very specific schematics, we're not able to really trace down. One thing I just thought of, and actually, because of David, he says that that could be a 3.3 volt line. What we can do is we can check and see what those pins actually are on this MacBook Air to get a better idea if they're power lines or if they're data lines. So let's do just that. Let's pull up the schematic for this MacBook Air, which I pulled up last. And here is our chip. I'm going to rotate it in the same orientation of what it looks like on our A1708. So it's the fourth one and the fifth one down. And it looks like USB debug top P, USB debug top N. Not sure if this chip is actually important, because I would imagine that means if the device is getting any signal at all from these lines, it's going to put it in debug mode. Yes? No? Pin 19, 18, yeah, right here. USB-C debug top. It's a bidirectional line. Let's see where this goes to in the schematic. Which is strange, because if I look at this on a MacBook Air, this particular part of the USB-C is what it connects to. But whenever I measured, and I need to go back and measure again in case I missed something, when I measured that particular pin to a spot on the donor dead CPU MacBook, nothing really beeped for continuity here. This might not be an important line. So let's see where this is located else in the schematic. Okay, so it looks like there's a diode that connects to ground. Debug Bux 2. Schottky diode. How do you pronounce that? Okay, let's see what this goes to. And yeah, this right here is our USB-C port or connector, which that we might be we might be okay with just replacing that chip and leaving a hole there. And the reason I say that is because on our dead CPU, both dead CPUs, those are OL lines. They're not connected to anything. So if they're not connected to anything, but they go directly to the USB-C connector itself, is it, Schottky is what Tim says, is it possible that when this failed, it was probably on the USB-C side, the connector bridged a power line to one of those debug lines and ended up killing it. I am willing to try to see if we can just replace that USB-C connector, not the connector, the USB-C 3.0 chip, and see if it just works without it. Because debug might be a factory thing. That might not be anything that the computer requires in order for turning on. David says if it's USB, it must be 5 volts. As in, 5 volts was probably redirected towards the debug line and ended up killing it? Is that what you mean? So... Oh, sorry, I was just catching up on chat. Let's try it. Because worst case scenario, if it doesn't fix it, I don't think I'm going to be able to fix this one other than do a board replacement. So let's learn something new today. Let's see if we can live without those two particular lines, because they look like it's a debug line. It may not actually be something vital. So before we put a replacement USB 3.0 chip on there, we are going to fill in this hole with a little bit of mask. And I have myself here some black mask by Mechanic. I like the green mask better. It tends to do better in the UV light compared to the black mask. I think it just doesn't really allow. It's too dark for the UV light to actually try to go through the mask as it's curing. As you can see, I kind of made a mess, so I'm going to try to clean this up. Okay, so we got a little bit in there. I'm gonna do this probably 2 or 3 times just to layer that up. And before we do anything with the UV light, just because we want to make sure that we protect our eyes, you want to make sure you get some UV blocking goggles. And I have myself here a little UV pin that I can just point directly into. And you really want to make sure you don't look at this light underneath the microscope, because it just kind of amplifies the UV light through the microscope and can cause some serious retina damage. Alright, let's go ahead, clean that up a little bit with some alcohol and get another layer in there. And I think that'll be enough for us to start replacing this chip. And I made a mess last time just because I pointed the needle directly into that hole. I'm going to now get some mask and just put it on the tip of my scalpel here. Alright, let's go ahead and hit that again. David said shoddy diode, or Scotty diode, I'm sorry, works with low voltage and high frequencies, needed for supplies. Okay. Alright, let's try cleaning that up one more time. And I think, wow, my eyes always hurt whenever I take off the UV blocking light, or UV blocking goggles. Okay, I think that is good enough for us to see if this will work without that particular lines there. Last thing I want to do is just make sure that I don't have any mask covering anything here. I think we're fine. So let's go ahead and just take this chip from our MacBook Air. And conveniently, there's already flux on here from the last time we worked on this board. While it's heating up, let's see what's going on. The problem with USB-C is that the V-bus pins are right next to the data lines. Yeah. Having a power line so close to a data line, I'd say is definitely, it could be a design for improvement, but then again, I'm not a chip fabricator, so I'm not sure if that was an oversight or if that was intentional. Before I bash a design, I feel like I need to be armed with the knowledge of how you make this stuff in the first place. I'm just giving them the benefit of the doubt. I'm not sure why it was designed that way. Now, I do agree that having a power line right next to a data line on a MacBook screen is a really poor design, and that is not chip fabrication design. That is straight up Apple design. This chip wasn't designed by Apple. So, it's a lot easier for me to throw some sass at Apple for their poor designs, but I'm not sure about this particular chip. Or USB-C, because that's going to be through Texas Instruments. What kind of chip is that? We can Google for the data sheet. This is a PI3 USB 3220. Hold on. Hold on. It is a PI. Actually, hold on. I got it pulled up right here. Be easier if I just pull it on here. U3000. It is a PI3 USB 3 32224. You can also look up a 32224. I think they're pretty much the same chip. I lost a little rubber piece from my USB-C. Let me put that back before I forget. Alright, so now that I got some flux in there, let's go ahead and line up this replacement chip. Alright. Now to make sure we don't blow the chip away, I'm going to drop my air output to 60. It's about half the output that it normally does. And I don't want to apply flux yet because I want to wait for this to try to solder to a pin. If I put too much flux, it's just going to kind of flow away. Like that. Just like that. Put this back in its home. Like Happy Gilmore said, are you too good for your home? Just go in your home. My staff says I don't have that strong of a YouTube personality. I need to be more like Mr. Beast. Need to make sure to like, subscribe, and smash that bell. I didn't put any new solder down on the pads. I'm just using the solder that was actually on the chip. Once I can get this to wiggle into place, I'm going to push the chip down to really squeeze the solder onto the pads. Okay, so it looks like the chip is starting to melt. Let's go ahead and crank up our airflow. And I have it skewed just a little bit, so I should see this chip kind of wiggle up and to the left. There we are, some more pads are starting to solder. The surface tension should just pull it any second now. Okay, so it just moved over a little bit. And now I'm just remelting it again, so all the solder can come out of the pads. All right. Now, while the board is still hot, I'm going to flip it over and we're going to do the same thing to our CD3215 that died. I'm going to go ahead and replace it with another CD32 that we have here. And I don't need to worry about applying new solder to the pads because this CD32 has already been reballed. Now, comes to orientation, we reference this CD32 and it looks like pin 1 is going to be facing the bottom left, so we're going to do the same thing. Now what I did differently to this board compared to what I normally do, for the sake of diagnosing, I just pulled the chip off, but I should have marked the corners. My tweezers are broken. I need a new pair of tweezers. Okay, this will have to work. I didn't mark the board where the corners of this CD32 came from. So I'm going to have to eyeball it. I have to put a thin layer of a flux down. Sorry, my tweezers are now broken, so I'm having a hard time with gripping the replacement CD32, so I'm going to use a different pair of tweezers I have here. Okay, so I'm going to have to eyeball this, and what I like to do is look at the the pads here, and try to get it lined up with the actual chip, so it's in the middle. Now I can just kind of push it over. I think that's a little low. Okay. This should be lined up enough. It is a little low, but as we heat this up, it's going to pull itself up. It's the same thing we did earlier. I'm going to lower my air so that the chip doesn't blow away. David says, look what I found. Did you find the data sheets? I'm going to have to read that in a second. Trying to look in my peripheral at that while also soldering this. So, one moment. Alright, let's apply a little bit of flux so this will start to flow into place. And now it looks like part of the chip has melted, so I can crank up my air output. Any second now we'll see this chip kind of wiggle. There it goes, it's starting to slide, and it just slid up exactly like I thought it would. And we're good. Alright, we're going to let this cool down for a minute. And let's see, what's David saying here? U3000 and could see 4 pads completely destroyed as well. Pin 15, 16, 18, and 19, meaning 4 wires had to be run from the Pi 3 USB 32 chip to the specific diodes in order to repair. In order to repair these damaged pads and traces, U3000, which is the USB 3 chip, sorry, lost my train, acts as a USB-C support, and these models dealing with USB data plugged into the USB-C port. And that's for U3000 on a MacBook Air. That I have confirmed by looking at our schematic here, does go directly to some diodes. However, I don't think we had that, because we can also see that they go directly to the pins here on J3300, which is going to be what the actual USB-C plugs into on this MacBook Air. But when I did a continuity measurement between, actually hold on, what did I do it between? Oh, okay, this was on the donor board. Lost my train of thought there. When I measured continuity, specifically on pin 18 and 19, directly to where our USB-C is soldered on the underside of the board, I didn't get a beep or any type of continuity. So hopefully, this particular A1708 does not require those diode mode chips. You know what, let's find out. Let's find out while I'm still working on this board. Where did I put that dead CPU board? Let's see. Alright, so we're going to touch pin 4, which I think is actually pin 18, and I'm going to go through and touch each one of these pins, which is the bottom side of our USB-C. Slide up a little bit. It's a little hard to do that with my face in the scope. Oh. Oh no. Okay. I see. We actually do have a line there. Did you look at the pins on the port? If so, I missed that. We may have to run some jumper wires then from pin 18 and 19 underneath our Thunderbolt cowling, the thing that's actually covering the USB. Oh, but does the computer require those debug modes? Let me reread what David said right here. U3000 and could see 4 solder pads on the logic board had been completely destroyed as well. Pin 13, 16, and 18, 19, meaning 4 wires had to be run from the particular USB 3.0 chip to these respective diodes in order to repair these damaged pads and traces. U3000 acts as a USB-C support on these models dealing with USB devices plugged into USB-C. David says it must be a 5-volt line. Look at the diodes. All right, so that we actually can do on our particular schematic that we have here. So let me go back and see exactly. What I see it as now is there's so much flux in this particular pad that I wasn't getting a good reading here. So let me see. 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay, 8 from the bottom. Let's look at that on our schematic here. We need to go back to our schematic for the 2017 A1708. And that's this side, and we went 1, 2, 3, 4, 5, 6, 7, 8. And it's this particular diode. Now, we may not have to necessarily solder to that diode, but instead could just solder directly to pin 43 of our USB-C. And here's the annoying thing. You could see on the schematic where that particular chip would exist, or at least where the via is. And it goes directly to U3100. So hopefully U3100, which is our other CD32, isn't dead. So let's take, in order for us to take a look at these diodes, we will need to remove the cowlings right here. Okay, hear me out, because I've already done this. I want to see what happens with this device. Now, you say USB-C devices, so we're probably going to get power now. We're probably going to get power. I'm sorry, I hit the wrong camera. But we may not get data lines. And if so, then yes, I will have to run some jumper wires. Let's see, what do we get here? Are we going to get a pop? Is something going to explode? Pin 42 and 43 is what David is saying. Oh, looks like I have a power cycle going on here. Yep, power cycle. $14, 20 volts. So we're getting 20 volts on this particular USB, and power cycle on this side, which is probably, sorry, which CD32 is that? That's going to be U3100. So either we have some dead diodes, or USB or the U3100 died as well. We're gonna David's suggesting to check the diodes, which I agree is a good idea. The thing that's unfortunate is that our diodes are directly underneath this metal shield here. So let's just go ahead and remove that. We pretty much have no other choice at this point. So we're really gonna have to go around in a circle heating this up. Because now we either have another bad U3100, or this computer really does depend on a connection between those diodes and the USB 3 chip in order to function. Because it looks like those particular diode, or that particular line, goes directly to U3100. So being that we had a hole in this chip, and U3200 and not U3100 is interesting, because it looks like that particular line goes directly to U3100. Then again, we only have half a schematic here, so I'm not sure if U3100 is also joint to U3200. All right. Cowling has been removed. Make sure these little rubber pieces don't run away. And let's take a look at these diodes. You can also get a diode mode measurement now that we've dug up our traces. 1, 2, 3, 4, 5, 6, 7, 8. So it was this one. Okay, so measuring in diode, I have open line. And if this is connected directly to a diode, I would imagine I would be getting some sort of reading. So yeah, I would agree that this diode has probably failed. Or maybe it's fine, only because when I checked with the dead CPUs, those particular lines were also OL. So maybe we had that partial short on those specific traces. The question is that the board is 820000840. Correct, it is. let's look and see where said diodes would be. So 43, looks like this particular diode, diagonal, sorry, wrong one. So pin 43 is connected directly to this diode. So that would be this one right here. Which, looking at it, visually, and whenever we measure that particular diode mode measurement, we don't have a short. Okay, let's look at 42, which is directly underneath it. And that one looks okay as well. No bad readings anymore. And that diode is directly next to that one as well. So it sounds like that we're going to have to go ahead and replace U3100. And then that's going to fix the rebooting that we're getting with our USB-C. And then for any USB-C controller or data lines, we're gonna have to run a jumper wire to these particular spots. Okay, let me go ahead and replace U3100, and we'll address that. Admittedly, I've probably spent more time than I'd like to on this particular logic board, but I'm too invested at this point. Okay, I just had to grab another chip out of the back. Alright, let's work with this. The nice thing though about the A1708 is since the actual charge port is soldered on to the logic board itself, I can actually just run a jumper wire directly to that pad rather than to the diode. Okay. Now I need to grab some wick. And now we're just gonna wick up these existing solder balls. Oh, that capacitor moved, but we'll fix that. I think I have too much solder existing on this wick, so I'm gonna have to get another piece. But first, let me see if I can push this capacitor back into place. There we are. We're good there. The chip in the board view. If you're referring to the USB 3 chip, it doesn't exist on the actual board view, unfortunately, which is why I was referencing that of a MacBook Air. And you're saying to check the diodes. I did test that specific line on the back of the USB-C chip, or USB-C port, which is directly connected to the diode, and when I measured, I had an OL, which tells me that the diode hasn't shorted, unless I'm looking at that the wrong way. 1 second. Okay. Sorry, just getting a phone call. I'll have to answer that in a minute. Okay, so let's go ahead and get some new flux on here just to kind of make this tacky so the replacement CD32 won't necessarily flow away instantly. And let's get it lined up. Tim says, I have a pile of 820s 3115s I need to fix. Those are 2012 unibody 13-inch MacBook Pros. Those surprisingly still have a lot of value. We've still been fixing those and putting some out for refurbished computers to sell. It's because it's the last unibody that runs Catalina, which is still an okay operating system. Okay, so just like what we did before, let's line up the chip. And then push it over. Okay. Now let me turn down my airflow. And start heating up this CD32. Okay, let's add a little bit more flux here. Really get this kind of flowing underneath. And it looks like our solder is beginning to melt, so I should be able to increase my air output. And there we go. So the CD32 just completely slid into place. We're good there. HDMI, Thunderbolt, USB, all in one. That would be, yeah, the A1702s. Those are good machines. I personally have an A1398 that I use as a daily driver. It's a 2015 15-inch MacBook Pro. And it's a pretty solid machine. I love being able to have USB, Thunderbolt, HDMI, SD. I love the size of the screen. And I don't really have any intentions on upgrading it when it comes to the point that just the operating system just 100% will not work. I'll either dual boot it with Windows or have Linux on there. Alright, so that's still a little warm. Let me cool that down. Alright, so if you remember, when we tested this USB-C port, it was getting 20 volts and booting amperage. This side was power cycling, and my theory is because that particular data line, perfect, looks like 15 volts, 20, and booting amperage. Okay. So what I was saying though is this particular chip, the USB 3 chip that had failed, was also directly connected to U3100, but it also made U3200. Those are the two CD32 chips explode. So now that I've replaced that, we've restored power to this computer. The computer is getting 20 volts. Current, it was pulling about, I think it jumped up to 0.6 before I unplugged it. But typically that's around booting amperage. So the power restoration, or power has been restored. I don't know about the data lines, unfortunately, because we haven't ran any jumper wires to this debug port. So we can go ahead and run some jumper wire. I got 10 minutes left before the end of the day. to bring back the data functionality of it. And for that, I actually need some jumper wire. Boot maybe no directional datas. You don't want to try without jumper wires. I mean, okay, we can try. We can try and see what happened with the debug lines completely removed. We probably have to do the job right and still run data lines afterwards, but let's find out. Let's find out if this machine will run without data lines. I also have the same board and problem. Did you plug something into it that drew too much power and ended up killing it, or is the computer just a no power issue? Let's see. We'll see. We'll see if this guy turns on. This MacBook is alive. I feel very confident we're going to get power. But are we going to get the data lines? Let's just plug in the essentials. Don't really care about the speakers, personally. We do need the keyboard plugged in, though. That's pretty important. Trackpad. Let's get our Wi-Fi. Now, I'm going to boot from a test drive that I have here. It's an external SSD for testing reasons. And for privacy reasons, don't want to plug in a customer device for testing this on a live stream. Tim says, yay, science. Science rules. Okay, so all of the necessary lines are plugged in. I just left the speakers unplugged. Test drive. Now, since it had that level of short, I also assume this is not going to turn on just battery. The battery is probably stone cold dead. Oh, I stand corrected. Sorry, I turned away. There's no SSD in here though, so don't let that Apple logo troll you. I am, however, going to do an SMC, just so I can reboot it and option boot. Are you getting juicy YT money? I get about 30 bucks a month. For those who are curious. It's about $100 every quarter from YouTube. It's nice because I buy pizza every Friday for everyone here. So YouTube indirectly pays for our pizza. Okay, so right off the bat, what does this tell us? I'm booted externally, or I'm option booting at least. So that tells me I have a data line. So far, so good. Let's flip it over, or not flip it over, but let me plug in the cables the other way to see if I'm getting a data line. We must bring you to a higher level. Yay, data lines are working. Better than zero. Yes, I agree with everyone on stream. Thank you so much. So let's go ahead. I'm going to improperly eject my external drive. And now we're going to plug this in. And I'm probably going to have to restart the computer. It may have not liked me rebooting or unplugging everything. Or that could be our issue too. So let's do an SMC reset. And then let's hold Option and see if now the external SSD works on the other port. Yep, and we have data on the other side. I'm going to go ahead and boot into a test drive real quick. I'm not sure if we need to actually... We'll do test Catalina. I'm not sure if we actually need to run a jumper line for the debugs, for those particular debug lines, because the computer may not utilize it. I'm also going to have to test to see with external display to see maybe that's when it uses it. So I'm going to actually try that before this live stream is up, but sorry, I was just checking something real quick. My test monitor is actually turning off as we speak. So let's boot back into our overhead camera. Check if it charges. I think it will, just because we were pulling a higher amperage, but I do have coconut battery for testing the battery here. Cool. Password is in fact test. Company secret. That's just for our test drives. No drink in the work zone. That is far away. Okay, let's grab our USB-C to HDMI adapter and plug it in and see if we get any type of external display. Because we know the data line is working since we're booted with a USB SSD. I want to plug in this cable without messing with my SSD line, accidentally unplugging it while I'm booted into the machine. And let's take a look here and see what we have. Now, you're all just going to have to trust me because I have a monitor up here and I have display. And just so that you guys can see, because I don't feel like moving my camera right here, so when I go to my overhead camera, I'll go and navigate to my display settings, and we should see two separate monitors. Yep, you can see there's the internal screen. Actually, I'm not sure which one's the internal screen, but the smaller one I would imagine is the internal screen. This is going to be a television that I have mounted to the side. So we're fine. We are getting both power, data, since we're booted through a test drive, and HDMI functionality through the Thunderbolt controller. I don't think we need the lines on the specific model. Now, I'm going to call it a day here and run through a more intense quality control test to see if there's something that this may be affecting. But truthfully, I think just by ripping out those existing traces, we're perfectly fine. I will follow up and leave in the description or have a second video if there is a further issue here. But truthfully, I think we're good. So cool, that is a successful board repair. So let's go ahead and just kind of recap real quick what was wrong with this computer. It looks like someone plugged in something into here that drew a lot of amperage, whether it was a cheap aftermarket adapter, something that increased one USB-C to like a 10 USB port. Saved you from jumpering. You're absolutely right. I appreciate the suggestion. So something was plugged into here that ended up frying our U3100. It daisy chained to the U3100 is the USB-C charging chip, the CD32. It then daisy chained and killed the USB 3 chip, and then also blew up our U3200, our other CD32, our other charging USB-C chip. So after replacing all three of those, it looks like this was a successful repair. So are the port pins okay? The port pins looked perfectly fine underneath the scope. And I mean, yeah, we did data, we did power, we did HDMI, all that seems to be working. So awesome. I love them when these work. So I appreciate you guys joining me. We close in a minute, So that's it. I'm going to go home, enjoy the rest of my evening. I hope you guys enjoy the rest of your evening as well. Have a good night. Coworkers are disturbing the autofocus. All right. We'll talk to you guys later. I got another board. I think I have 2 boards lined up that I got to get done this week. So I'll be doing those live stream as well. Later.